Okay, our last method for solving systems is the elimination method. So method 3, elimination. And this is best set up when you have like both your x terms first, both your y terms first, your equals line up, and then your constants line up. And so it's called the elimination method because it consists of adding two equations together to eliminate either the x variable or the y variable, giving you an equation that can then easily be solved because then you only have an x or you only have a y. Now, to be able to eliminate a variable, the coefficients, or the number in front of the x's, or the numbers in front of the y's, must be the same number, different signs. And so that's our number one goal, is do we have same number, different signs? So when I look at my equation, my system, I want to look, do those x numbers match or do those y numbers match? And if they don't, then there's a certain thing we have to do before we can add them together. So we're going to look at our first system right here. We have the negative 4x plus 7y equals 30. And then we also have a 5x minus 7y equals negative 34. And as we can tell here, our y's match. They're the same number, different sign. And so that means that we have the ability to add these two equations together. So we're going to go ahead and add them. So a negative 4x plus 5x gives me 1x. The 7y minus 7y becomes 0. And that is equal to 30 minus 34, which is negative 4. And so right away, I've got that first value for x, which is amazing. I love it. And so there's my first answer. Now I have the ability to go back to one of the original equations, and it doesn't matter which one I use. I can use the top one or the bottom one. And the picking does not affect my answer. So you could use the first one, and I could use the second one, plug that back in, and we would end up with the same answer for y, as long as we did our math correctly. So I'm going to go ahead, and I'm going to use the first one. So I have negative 4x plus 7y equals 30. And now we're going to use the idea of substitution. In that x spot, I'm going to put negative 4. So this is now negative 4 times negative 4 plus 7y equals 30. And negative 4 times negative 4 is 16 plus 7y equals 30. And now we're just going to solve for y. So I move the 16 over the other side. So I'm minus 16 on both sides. And now I have 7y equals 30 minus 16 is 14. I divide by 7. And we now have our y value of 2. And most people find the elimination method their favorite. But each method is set up nicely for one method or another. So if they're both y equals and they look easy to graph, you could graph them. If only one of them is a y equals or one of them is an x equals, it's set up perfectly for your substitution. If they're both written in this form where your x's line up, your y's line up, your equal signs line up, then it's set up for the elimination method. So each method does have its own purpose. Now keep in mind, these are two lines intersecting, so my answer should represent where do these two lines intersect. And so it is a point with the coordinates x, comma, y. And there is our solution. So let's take a look at another. And now we're going to take a look at, well, what happens if they don't line up? So when I look at my equation, I've got a 4x and a 7x, not the same number, different signs. For the y's, I have a 3y and a negative 6y, not the same number, different sides. But I do have the ability to multiply my equation. So I can multiply the entire equation by a number to get a new version of the equation, which is kind of like giving the equation a makeover. It's the same equation, just a new look, so that way we can get those numbers to cancel out. And when I look at my system here, it looks like I can take this top equation and I can times by 2. If I times by 2, it's going to turn this y into a positive 6, which then I have a positive 6y and a negative 6y, same number, different signs, and I can add them together. So I'm going to times the whole top equation by 2. So 2 times 4x gives me 8x. 2 times 6y, or 3y gives me 6y. Equals, and then 2 times 19 gives me 38. So I'm going to rewrite my system. The bottom one does not need to be changed. Stays exactly the same. And now because I have that same number, different signs, I can add these together. And you have to be careful. They have to be the same number, different signs, or else when you add them together, they don't turn into 0 and they don't cancel out or eliminate, which is how we get the method name of elimination. So when I add these together, these do eliminate. 8x plus 7x is 15x. A 38 minus 23 is 15. I divide by 15 on both sides. And x is equal to 1. And now I can use this to plug back into either one of my equations, and it doesn't matter, again, which one. I can use top, I can use bottom. I'm going to go ahead and use the top one. So we now have 4x plus 3y equals 19. And since I know x is 1, I'm going to put that 1 in the x spot. So this is really 4 times 1 plus 3y equals 19. 4 times 1 is really 4. And now I just have a two-step equation. So I'm trying to get the y by itself. I'm minus 4 on both sides. So now I have 3y equals 15. I divide by 3 on both sides. And y is equal to 5. And again, I can't emphasize this enough. This is two lines intersecting. I want to know where they intersect. And the point of intersection is x comma y. And that is the location of the solution. Okay, so we're going to try another. We have 2x minus 3y equals 20. And then we have 11x plus 2y equals negative 1. And so now, neither one of them seem really easy. So it's really our choice. I can either make the x's the same number of different signs, or I can make my y's the same number of different signs. And it's really our choice. As long as you do your math correctly, you should end up with the same answer. Because I like smaller numbers, I'm going to go ahead and work with the y's. So I want to change the 3 and 2 into the same number of different signs. So 3 and 2, if I multiply them together, I get the number 6. So I'm going to turn them into the number 6. So I'm going to multiply my top equation by 2. And I'm going to multiply my bottom equation by 3. So when I multiply by 2, 2 times 2x is 4x. 2 times minus 3y is minus 6y. And 2 times 20 is 40. And now I'm going to go ahead and take the green. And 3 times 11x is 33x. 3 times 2y is 6y. And 3 times negative 1 is negative 3. And then I just double check. Do my y's have the same number of different signs? Yes. So when I add them, I'm going to have 37x. These cancel out, become 0, equals 37. Now I just divide by 37 on both sides. And I get x equals 1. And so there's half my solution. So now I'm going to go back to one of my original equations. It doesn't matter which one. I'm going to go ahead and use the second one this time just to be a little different. So my second one is 11x plus 2y equals negative 1. Since I know x is 1, I'm going to put that in the x spot. So this is really 11 times 1 plus 2y equals negative 1. I then multiply 11 times 1 is really 11. So 11 plus 2y equals negative 1. I subtract 11 on both sides. So now I have 2y equals negative 12. I divide by 2 on both sides. And y equals negative 6. And so now I have an x value and a y value for the point where they intersect. So I have to write it as a coordinate. Where do they intersect? They intersect at the point x comma y. And that is my solution. Okay, let's look at another one. Now we have a word problem. So now we're going to have to practice how do I set these up. So I have the sum, which means I'm going to add two numbers. And when I add two numbers, I get 28. So I'm going to pick two letters to represent my variables. So I'm going to use x and y just because x and y are easy to use. So I'm going to add two numbers, x and y, and my answer is 28. Now, the difference is 6. So difference is when I subtract. So x minus y gives me 6. And the thing I like about these problems is when you do the sum and difference ones, they're already set up to add together right away. So I can add these two together. And so this is really a 1x plus 1x, so I get 2x. We get a 1y minus 1y, which is 0, equals, and then 28 plus 6 gives me 34. And now I divide by 2 on both sides, and I get x equals 17. So one of my numbers is 17. Now I can plug this back in to find the other value. So I'm going to use the first one because it's the easiest. So my x plus y is 28. So if my x is 17, the 17 plus what number gives me 28? So I minus 17 on both sides, and I get y equals 11. And then I just double check. 17 plus 11 is 28. 17 minus 11 is 6. We're good to go. So my numbers are 17 and 11. Okay, so now we're looking at the more complicated problems where we truly use systems more in kind of a business sense. Nowhere near as complicated because true business, in fact, most business majors have to take a calculus for business because the information you use to run a business is way more complicated. But this gives you an idea of how math is used. So I have 3 pairs of jeans and 6 shirts that cost $104.25. So I have 3 jeans called jeans X, and I have 6 shirts. Okay? Now I'm not associating this with the cost. Actually, I am associating with the cost. So that is $104.25. Now I'm going to look at my next one. The cost of 4 pairs of jeans, so 4 jeans and 5 shirts, is $112.15. And so now I have my system set up just like the elimination method. My x's line up, my y's line up, my equal signs line up, my numbers line up. And so now what I want to do is I want to try and either get my x's to cancel or my y's to cancel. Now I like smaller numbers, so I'm going to try and get my x's to cancel. So if I have a 3 and a 4, I want to turn both numbers into 12. So I can times this one by 4, and I can times this one by 3. But if I do that, I get a 12x and a 12x. And the idea is that I need them to cancel, so one of them has to be negative. So I need to multiply one of them by negative. I'm going to go ahead and choose the bottom one. And so now I'm going to go ahead and rewrite the system after I multiply. So 4 times 3x gives me 12x. 4 times 6y gives me 24y. I'm going to have to grab my calculator because I have no idea what 4 times 104.25 is. So 4 times 104.25 gives me 417. Yay, no more decimal. And so now I'm going to go ahead and multiply on the bottom. So negative 3 times 4x gives me negative 12x. Yay. Negative 3 times 5y gives me negative 15y. And then negative 3 times 112, I'm going to need that calculator. So negative 3 times 112.15 gives me a decimal, an ugly one too, negative 336.45. But now I have the ability to add these together. So I can add these together. Yay, the x's cancel. So 24y minus 15y is 9y. Now I'm going to do 417, subtracting that decimal. Oops. 417 minus 336.45. And so I get 80.55. Now I divide by 9 on both sides. And I can figure out the cost of y, which is the shirt, which is $8.95. So $8.95 a shirt. And that tells me the cost of my shirt. So now I can go back to one of my original equations and I can figure out the cost of a pair of jeans. So I'm going to go ahead and go back to the original. I'm going to have 3 times x plus 6 times my new y, 8.95, is equal to 104.25. So now I'm going to do 895 times 6. So now I have 3x plus 5370 is equal to 104.25. I subtract 5370 from both sides. So now I have 3x equals 50/55. I divide by 3, and I should figure out the cost of my jeans, because that's x. And my jeans are $16.85. And that's our word problem. So I believe from here we're just going to go back and practice regular systems. So I have 5x minus 3y equals negative 36, 2x plus 3y equals 15. And when I look at this, I'm looking, do my x's cancel, do my y's cancel? And my y's cancel, so I don't have to do anything to it. So I go ahead and I add these together. 5x plus 2x gives me 7x. Negative 3y plus 3y gives me 0. And that is equal to negative 36 plus 15, which gives me negative 21. I divide by 7 on both sides, and x is equal to 3. Now that I know my x value, I can go back to one of my original equations and solve for y. So I'm going to use the second one because it has less negatives, and I don't like negatives. So 2 times my x plus 3y equals 15. So 2 times 3 gives me 6, plus 3y equals 15. I minus 6 on both sides. So now I have 3y equals 9. I divide by 3 on both sides, and y equals 3. And so now I have my solution. It is a point on the graph, 3, 3. Now we have one more problem. And so now when we look at it, we've got 3x plus 2y equals negative 1, 4x minus 5y equals negative 32. And now I have to decide, what am I going to try and cancel, my x's or my y's? And I'm going to go ahead and go with my y's this time. So if I have a positive 2 and a negative 5, I don't have to worry about switching signs because one's already positive, one's negative. So I just need them to be the same number. So 2 times 5 is 10, so I'm going to times the top one by 5, the bottom one by 2. We're going to go ahead and multiply that out. So this is now going to turn into 5 times 3x is 15x. 5 times 2y is 10y. And that's equal to 5 times negative 1 is negative 5. And then on the bottom, we're going to go ahead and multiply 2. So 2 times 4x gives me 8x. 2 times negative 5y gives me negative 10y. And then 2 times negative 32 gives me negative 64. So now I add it together. So 15x plus 8x gives me 23x. 10y minus 10y becomes 0, and that's equal to negative 5 plus negative 64, which is negative 69. Now I divide both sides by 23, and I get an x value of negative 3. Now that I know my x, I can plug that back into either one of my equations, and I can solve for y. So I'm going to use the top one. So 3 times my x plus 2 times my y equals -1. So this becomes -9 plus 2y equals -1. I add 9 to both sides. So now I have 2y equals 8. 9 plus -1 is 8, or 9 minus 1, or -1 plus 9. Either way, 8. Divide by 2 on both sides, and y is equal to 4. Now remember, this is a point where the lines intersect, so it's an x comma y. And that is our solution. So that's our 3 methods for solving systems. Next time, we're going to talk about special cases. And so what do we do then?